Morning.
Good morning, Mr. Olum.
Okay, we have a new topic here. Which topic is that?
Acids, bases, and indicators.
Now, we want to introduce this. We have acids, we have bases, and we have indicators. Is it the first time you are coming to hear these terms?
No.
Yes, very fast. Who can tell us what an indicator, sorry, an acid is? Acid? Anything you know about an acid? Yes? It makes something taste sour, right? A corrosive substance. Any other? Okay. Now, acids are substances that have, you don't write, you leave your notes, have sour taste. Can you give me examples of substances that have sour taste? One? Lemon. Lemon juice. Right? Sour. Sorry? Chili. Sour milk. Vinegar, right? Lime, right? Bases, yes, something you know about bases.
Substances that have
Bitter taste. The taste of bases is bitter. They have bitter taste. Example, what is having a bitter taste? Example? Yes. We have so many salts. Which salt? Have. Okay, the best example we have here, we can talk about wood, ash. And another example, we have sodium hydroxide. You can also have potassium hydroxide. So we have learned that acids are substances that have sour
taste.
What of bases?
Substances that have bitter taste.
Some of the few examples are here, right?
Yes.
Now, there is a very important role that is played by indicators. Indicators are also substances. Indicators are substances that produces colors when added to acids or bases. They produce different colors when they are added to acids or
bases.
In this lesson, we are going to talk about simple acid and base indicators. Simple acid, base indicators. We want to extract an indicator from flower petals. That's what we're going to do now. Now, before we start doing that, we learned about extraction of solvents, right?
Yes.
Very fast. Who can tell us how we extract solvents? Very fast. Extraction of solvent? Yes.
You put the mortar.
Extraction process, yeah.
You put the leaves in the mortar.
Yeah.
You use the pestle to crush them. Then you add propanol to it.
Yes.
Then you leave it in the sun for the propanol to evaporate. Yes. And then the simple test for solvent extraction is a patch on a pen.
Okay. Clap for her. Very fast. What is the function of why are we using propanol in that extraction? Why are we using propanol?
Because of the
Yes. the flower. Very good, very good, very good. So we'll be extracting an indicator from this petal here. Is that okay?
Yes.
The procedure remains the same. One, you put the petals in
The mortar.
the mortar. Then what do you do? Using.
A vessel.
Then what do you do?
Add propanol.
Add propanol. Then here we will decant. So the solvent that we're going to decant, the solvent we're going to decant from this process will be an indicator that is extracted from the flower. Right? We are here. We are here. This is the petal. This is the petal. Remove it. Don't remove the green part. Just have which color is this?
Red.
Have it. Have it. Everybody put it there into the mortar. Remove the two of them. Are you there?
Yes.
Crush, 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 crush. Small section. Not there. Are we there?
Yes.
Now. You can. I have a solution labeled here.
Goulash.
And if you come back here, we gave an example of goulash where?
Basis.
Yes, so we want to know the color of the indicator when we add it to goulash, which is a base. Is that okay?
Yes.
And therefore you come for a solution, the sample here. This is our indicator. So what we are going to do, having goulash as our base, as we mentioned there, we will be adding few drops of this indicator into this solution, and then we record the color. Is that okay?
Yes.
Yes. So come for the goulash.
Just hold on.
Yes. Now please. hydrochloric acid so that we see the difference in color. No?
Yes.
I'll be giving you hydrochloric acid, then we see the color changes. Then we compare, right?
Yes.
Okay. Okay, you also come from the droppers. You come for the droppers. Orderly. Proper. You did not take that. Wait. Now, get this. Have few drops of the extract, the indicator, have few drops you add into the solution that I've given you. Then you check around, you take the indicator, you add into the solution. The indicator into the solution. This is the indicator. Then add it. Okay? Just add the indicator into the solution. Indicator into the solution. This is the indicator into the solution. Get this? This is the indicator, right? That we have extracted. You add this indicator into the solution that I gave you. Which solution is this? Wood ash. So you add the indicator into wood ash, then you check the color. Yes, what did I give you? This group, hydrochloric acid. Let us compare the colors of these two. Are there differences in color?
Yes.
This was wood ash and this is hydrochloric acid. The colors are different. Why are the colors different? Indicators have shown different colors in these two solutions. Are we together?
Yes.
This is the acid, this is a base, and this is an acid. Right?
Yes.
And we are seeing the difference in colors. However much they are close, but there is a difference in the two colors. Right?
Yes.
Can you compare? Each table, compare. Compare the colors that you have. You can check.
Acid.
Now, I want to compare the hydrochloric acid from this group and from this group. And then we see. Bring it over. Let us see. Let us check the colors of the two. Are they the same?
No.
Be very careful. This was hydrochloric acid. Hydrochloric acid. They are the same. It's only that the intensity of this is very high. Check.
Yes.
Are you seeing?
Yes.
If you compare with wood ash, it is far. Very far. We can compare the next group and see. The same color that we obtained from the other side. The same color. There's hydrochloric acid there?
Yes.
The colors, the same, right?
Yes.
Right. Which groups have indicators? Now, we want to also see the color of the indicator when we add it to sulfuric acid. We have sulfuric acid here. We also have potassium hydroxide. Are we together?
Yes.
Potassium hydroxide is a base. Sulfuric acid is an acid. So I need two groups to come for the acid. Okay. I've given you potassium hydroxide. And is that an indicator? You point out the indicator, you are left to do that. Point out the indicator. Or you have another one? Fine. Sulfuric acid. Potassium hydroxide. Sulfuric acid. You want text? Propanol. It's here. Then you decant very fast. You want to see the color? Silent. You remember the color that we saw in the acid that we tested, the first round? Which acid was that?
Hydrochloric acid.
Hydrochloric acid. Now look at the color of the indicator in sulfuric acid. Are they the same? Just check. Who is having that solution of hydrochloric acid? Who is having it? Are you seeing how close they are?
Yes.
This is the color of the indicator in sulfuric acid, the color of the indicator in hydrochloric acid. So we are seeing that the indicators are having some colors in either indicators or, they are having distinct colors in either bases or acids. Are we there?
Yes.
Now who has done this one for sodium? Potassium hydroxide. Pass it over. Potassium hydroxide. Pass it over. Potassium hydroxide. Potassium hydroxide. Potassium hydroxide. Potassium hydroxide. Next. Potassium hydroxide. Okay, let us compare potassium hydroxide to the acid. Look. Remember, this is an acid. This is a base. You can see the difference in colors. This is an acid, that is sulfuric acid. This is a base, that is potassium hydroxide. This is potassium hydroxide, this is sulfuric acid. Look the difference in colors. It tells us that indicators show different colors in either acids or bases. Any question? Yes.
Okay, hold on. Let's okay.
So I have a question based on what you have just explained there. You have said that acids are substances that have sour taste.
Yes.
And one of the examples which you have listed is
Sulfuric acid.
Sulfuric acid.
Yes.
Does it mean that you have to taste the sulfuric acid in order to realize that it is an acid?
Okay. We once said that we should not taste any substance in the laboratory. The only way we can test whether substances are an acid or a base is by using indicators. There are special indicators. We have commercial indicators that produce distinct colors when we test or we use them in the laboratory. So here we are not going to test, but we will be using indicators to know whether a substance is a base or an acid. Right?
Yes.
Okay. There's another hand somewhere. Yes.
What makes the bases and what makes the indicators to change colors in acid and bases?
Pardon?
What makes the indicators to change color when it's put in acid or bases?
Now, we will be learning this later on. Acids and bases have different concentrations. What makes a substance to be an acid is the concentration of hydrogen ions. Is that okay? We'll be learning that later on. So what brings the difference in color is the concentration of hydrogen ions in those substances. We'll learn that later on in the classes that are next to us, that is Form 2 and Form 3 and Form 4, right?
Yes.
Okay. Yes?
Excuse me, sir.
Okay, yeah.
What is the difference between the hydrochloric acid we are using now and the ones we are taught that they are found in the stomach?
They are found in?
The stomach. The
This
hydrochloric
stomach.
acid, yes.
They are the same. but the difference is their concentration. This one here, we can manufacture them industrially, but the ones that are in the stomach, they are not manufactured. Is that okay?
Yes.
Yes. Yes, the two of you.
Add the indicators inside the acids, they change their colors.
Yes.
And now when we take the acids and put in the indicators, will they change their color?
Pardon?
When we take the acids and put inside the indicators, will they be pure as the indicators, as the acids?
If you take the acid you put into the indicator, the color will change. But it is advisable to add indicator into the solution in question. Right? Indicators we have, you've seen the small quantity of indicator we have. You simply add few drops of that indicator into the solution you are testing. Right? Okay. Yes.
What happens when you mix the acids, bases, and the indicators?
What happens
When you mix the three?
when you mix the three? Acids will always react with bases. We'll be learning this in this very topic. Acid reacts with bases in a reaction known as neutralization reaction. So the colors will be changing. We'll be talking about commercial indicators that produces distinct colors when you put them in either acid, base, or neutral solution. So acid reacts with bases to give us salt and water as the products. These products, the color of the indicator is distinct. We'll be talking about the commercial indicators in the next lesson. After some time, we can do that. We can check again. Is this color the same? We have stayed for like 5 minutes or so. The color is still this. Unless a reaction takes place, this color will remain. When the reaction takes place, we will know how the color changes, because the color of an indicator in neutral solution is different with the color of indicator in acidic solution. So the color will change upon a reaction. Okay. Yes.
Add water to the indicator.
What will happen if you add water to the indicator? Water is a neutral solution. Water is neutral. Now, if there is a color that is being produced when you add indicators to neutral solutions. So that color, for example, we'll be learning about methyl orange, we'll be talking about phenolphthalein, we'll be talking about litmus solution. I'll take litmus solution. If you add litmus solution to neutral solution, that is water, the color will be colorless. So there is distinct color. Answer. Neutral solution is a solution that is neither acidic nor basic. It is not a base and it is not sour and it is not bitter. And we said water is tasteless.
Potassium hydroxide.
This one is potassium hydroxide. Yes.
And this one is
This is sulfuric acid.
When you add them back together, they bring the color of the indicator.
No, they will not bring the color of the indicator. Remember, there's an indicator inside here. There's an indicator inside here. This is sodium hydroxide. There is a color of the indicator in sodium hydroxide. There is also a color of the indicator in sulfuric acid. If you react sulfuric acid with sodium hydroxide, I've said that reaction is called neutralization reaction. A reaction that will give us salt and water as the only products. So if I add this, they'll be reacting, yes. The new products that are formed are neutral. So there is another color that will come for this neutral solution when I mix them. You want us to do that?
Yes.
Let us compare. The other one is fading. Are you seeing the color is now different? It's different. It's not the one that we had before. There was one for the base and there was another one for the acid. Now if you mix them, reaction has taken place between sodium hydroxide and sulfuric acid. There are products here. What is inside here, they are neutral. There is a salt and water formed inside here. So the color that we are seeing here is the color of the indicator in neutral solutions. And if you happen to add the indicator that you are remaining with in pure water, not this tap water, in pure water, that is distilled water, the color will be close to this. Meaning there is a color of the indicator in neutral solution. Example of neutral solution? Water. Answer. Yes.
During this experiment, you can only use that petals, or is there something else that you use?
All right. We talked about extraction of indicators from flower petals. These are indicators that we have just extracted from this flower, right? Manually, we have just extracted this from this flower to get an indicator. In the lab, we are not using these indicators. We will be using commercial indicators. These commercial indicators, we have mentioned them: phenolphthalein, litmus solution, methyl orange. Those are the three main commercial indicators that we use in the laboratory. Right? Yes. So in the lab, we won't use this one here. We are using commercial indicators. Last question.
What are the applications of acids, bases, and indicators in real life?
In real life, we will learn that at the end of the topic. Will that help? Yes, we will learn that at the end of this topic, the applications in real life. The most immediate application is this. Let us say this is concentrated sulfuric acid. By accident, this concentrated sulfuric acid reaches your skin. It burns you, right? Yes. The only application or the only remedy that you can have towards that burn is to add a strong base to that spot. The reason why you are adding a strong base so that they react to form neutral solution. There is water there going to be formed and a salt. So that will help you not to continue burning. That is how we can apply it in the laboratory. Last question, please.
Share an example of a strong base.
Example of a strong base, we have potassium hydroxide, we have sodium hydroxide. There is a strong base, weak base, strong acid, weak acids. We will be having that in our next lesson. It depends on the pH values, the hydrogen potentials of the acids or the substances. Last one. Yes. Pardon?
How can you obtain indicators from the solution?
We can't get back our indicator from the solutions. Once you place them, you cannot get them back. Yes. I hope all are answered.
Yes.
How was the lesson? What did you learn very fast? What did you learn? What did you learn? Yes.
Acids are substances that have sour taste.
Yes, that is right.
Bases are substances that have bitter.
Have bitter taste. Yes.
Indicators are substances that bring out a color from acids and bases.
Indicators are substances that show different colors in acids or and bases. Yes.
Okay, let us. Can you next then?
Pardon? Allow kindly. Allow.
The indicator cannot be added water because it does not dissolve the solution.
Really? Really? Did you say that?
And you have
Say, we cannot add solutions into indicator. What we do? We add indicators into
Solutions.
It's litmus solution. Very good. Another example of backbench. Another example of indicators, commercial indicators. Commercial indicators.
yes.
Yeah, say litmus solution. Another one. Methyl orange or methyl orange. The last one. The last commercial indicator. Yes. Phenolphthalein. We will meet in the next lesson and we will have notes on the same when we meet. Is it tomorrow? Yes. Tomorrow?
Yes.
Alright, you have a good afternoon.
Stay tuned.
Just a quick one. We want to see something.
Yeah. go, then you go. Okay, just go. Then this thing will go, then come back.
I would want different faces.
Different.